Yes students, here we will discuss about polynomials. Chapter 2, polynomials in class 10. Polynomials we have learnt in class 9 itself. The expressions, algebraic expressions, 2x plus 3, 3x square plus 4x minus 5. Okay, all these are polynomials. Which is not a polynomial? The power of the variable should not be negative or should not be like a rational number. Power should not be a rational number, and power should not be in the form of like 1 by 2, 1 by 3, 3 by 4. So like the power should not be a rational number, and power should not be negative also. Okay. If suppose 1 by x, how we can write? This is nothing but x to the power minus 1. Square root of x. It is nothing but x to the power 1 by 2. Okay. So inside the root, square root, cube root, fourth root, whatever the root, the variable should not come inside the root, as well as variable should not come in the denominator. That means power should not be negative as well as rational number. So that if it comes here, we cannot say it is a polynomial. 2x plus 3 is an algebraic expression. 3x square plus 4x minus 5 is an algebraic expression. 1 by x minus 5, this is an algebraic expression, but this is not a polynomial. Okay, so all these are algebraic expressions, but only the power has the whole power, whole number. Power can be 0 also. X to the power 0 means it can be considered as 1. Okay, x to the power 0 is anything to the power 0 is 1. Okay, power can be a whole number. Power should not be an integer or rational number. So that kind of algebraic expressions are called polynomials. So here we will discuss about, in this chapter mainly we are discussing about quadratic polynomial and cubic polynomial. About linear polynomial we have discussed in our class 9 itself. Suppose y equal to 3x plus 5. It is a linear polynomial. The highest power of the polynomial is 1. So that we can say it is a linear polynomial. If the highest power is 2, then we can say it is a quadratic polynomial. Degree of the polynomial. The highest power of the variable is called the degree of the polynomial. So if the highest power, that means degree of the polynomial is 1, that is a linear polynomial. Suppose y equal to 3x square plus 4x minus 5. It is a quadratic polynomial because the degree of this polynomial is 2. Y equal to 4x square minus 5x plus 7 plus 3x cube. Okay. So the highest power of this polynomial is 3. So degree is 3. So it is a cubic polynomial. Next, 0 of a polynomial. Any polynomial, it is a linear polynomial, quadratic polynomial, cubic polynomial, whatever the polynomial, if you take y equal to 3x square plus 4x minus 5. Suppose if you are taking a quadratic polynomial, we substitute some value for x. If we find the value of the polynomial is 0, then we can say that the value of x is called the 0 of the polynomial. Suppose if you take a linear polynomial y equal to 3x plus 5. Okay, how can we find the 0 of this polynomial? We have to equalize this to 0. So 3x plus 5 equal to 0. That means 3x equal to minus 5, x is equal to minus 5 by 3. Okay. So minus 5 by 3 is the 0 of this polynomial. So if we substitute minus 5 by 3 here, this polynomial becomes 0. So x equal to minus 5 by 3. This minus 5 by 3 is the 0 of this linear polynomial. In the same way, we can find the 0 of the quadratic polynomial also. How to get the 0 of the quadratic polynomial? Suppose if you take a polynomial x square minus 2x minus 8, this is one of the polynomial. How to find the 0 of this polynomial? We have to get the factors of this polynomial first. How to get the factors? A x square plus bx plus c in this format. A and c we have to multiply and write here, and c we have to write down. So 1 into minus 8 become minus 8, and this minus 2 we should write here. 4 2s are 8, 4 minus 2 is 2. So we are subtracting, greater number sign is coming here, and here it is negative, so both are having alternate sign. So here x square is not having any coefficient, so directly we can take it is x minus 4 and x plus 2 are the factors. X minus 4 and x plus 2 are the factors of this polynomial. If we equalize to 0, either x minus 4 equal to 0 or x plus 2 equal to 0. Then only this product becomes 0, or both also equal to 0. So x minus 4 equal to 0 means x is equal to 4. This x plus 2 equal to 0 means x is equal to minus 2. So x equal to 0, 4 and minus 2 are the zeros of this quadratic polynomial. So for getting 0 of the quadratic polynomial, first we need to factorize the given polynomial. After that, value we are getting that variable value for that variable, that is nothing but the 0 of this polynomial for a quadratic polynomial. Same way, cubic polynomial also we need to factorize first. Then the factors, by the factors we are getting the zeros of the polynomial. So zeros of the linear polynomial, zeros of the quadratic polynomial, and zeros of the quadratic polynomial, cubic polynomial also we have discussed. Okay. So if you want to get 0 of a polynomial, what we have to do? We need to find the value such that value, okay, here p of minus 5 by 3 equal to 0. Okay. So for this polynomial, minus 5 by 3 is the 0 of this polynomial. For this quadratic polynomial, p of 4 become 0. Same way, p of minus 2 also equal to 0 for this quadratic polynomial. 4 and minus 2 are the zeros of this quadratic polynomial. Next, geometric meaning of the zeros of the polynomial. We have seen that if it is a linear polynomial, it has 1 0, isn't it? How many zeros we got for a linear polynomial? It is a linear polynomial. We have only 1 0. Here it is a quadratic polynomial, so that we got 2 zeros. Okay. So based on the degree of the polynomial, the number of zeros will increase or decrease. If it is a linear polynomial, it has only 1 0. That means in geometry, how can we represent, how can we say what is the meaning of the 0 of the polynomial? Means if we plot the graph for this linear polynomial, okay, for x equal to minus 2, x equal to minus 2, if we substitute in this equation, we will get y equal to minus 1. X equal to 2, if we substitute here, y equal to 7 we will get. So if you plot the graph, it will meet only one point on the x-axis. The line, linear polynomial means we will get a straight line. No? So that straight line will passes through only one point on the x-axis. So at this point, y value is 0. Minus 3 by 2, 0. So at minus 3 by 2, at the place of minus 3 by 2, y value becomes 0. Okay, the polynomial becomes 0. Y equal to 2x plus 3. Okay, so this y value, when it will be 0, so by the time 2x plus 3 equal to 0. If y is 0 means 2x plus 3 equal to 0, so the polynomial is 0. Okay, when we are getting this y value is 0 at x equal to minus 3 by 2. So minus 3 by 2 is the 0 of this polynomial. So if it is a linear polynomial, we have only 1 0. So in geometrically we can express the 0 of the polynomial in this way by plotting the graph of the given equation. If it is a quadratic polynomial, for this also, for each value of x, we can find the value of y. If x equal to minus 2, if we substitute in this equation, we will get y value. The corresponding y values we will get. If we plot the graph, it is a quadratic equation, we will get a parabola. Okay, this curve, upside curve. Okay, the curve, it may come like this, or otherwise the curve will come down way also. So if it is a quadratic polynomial, the graph of the quadratic polynomial either will be upward curve or downward curve. Okay, this parabolic curve we will get. So in this graph, for this quadratic polynomial, it is it is crossing the x-axis at two different places. At x equal to minus 1, y value is 0. At x equal to 4, also y value is 0. Okay, in both of these places, y value is 0. Okay, so this is a graph of the quadratic polynomial. So it has two zeros. Okay, this is one of the 0 and this is the another 0. This is a geometrical representation of quadratic polynomial. So in this case 1, we have discussed in different cases. In this first case, either downward curve or upward curve, but in both of this curve, it is meeting x-axis at two different places. It is meeting the x-axis at two different places. In this graph also, it is meeting the x-axis at two different places. Even though sum of the quadratic polynomial, we will get parabolic curve now. Here, this is also a parabolic curve only, but it touches the x-axis at only one place. And even in this upward curve also, only one place. That means, it has only 1 0. That means, both of the zeros are equal. It is nothing but, it has only 1 0. Both of the zeros are equal, then only we will get like this. Both of the zeros are equal. And in this third case, what it is showing now? It is not at all touching the x-axis. Okay, so it has no solution at all. Okay, the curve is not touching x-axis. The both upward curve also. This is a graph of one equation. This is the graph of the another polynomial. This is one of the polynomial. This is the another polynomial. In both, the graph is going away from the x-axis. So it has no zeros. So in three cases of a quadratic polynomial, either it has no zero, or it has only 1 0, or it has two zeros. So at most, a quadratic polynomial has two zeros. At most, at the maximum, it has two zeros of a quadratic polynomial. In the same manner, if we take a cubic polynomial if we plot the graph of a cubic polynomial, it meets the x-axis at three different places. Y equal to x cube minus 4x. So degree of this polynomial is 3. So it is a cubic polynomial. For this polynomial, for each x value, randomly if we take some values for x, okay, the corresponding y value we will get. If we substitute x value here, we will get corresponding y value. So minus 2, 0, minus 1, 3, 0, 0. So like that, if we get the points and plot the graph of the cubic polynomial will come in this manner. Okay, so that it is crossing the x-axis at three different places. Okay, so it is a graph of a cubic polynomial. The same way here, in this graph, this is also graph of the cubic polynomial. Here it is crossing the x-axis at only one place. In this graph, it is meeting the x-axis at two different places. Okay, so if we take the graph of the cubic polynomial, it may it may cross the x-axis at 1 place, 2 place, 3 places at the maximum. As it is a cubic polynomial, the degree is 3. It will meet x-axis at the maximum 3 different places. Okay. So the 0 of cubic polynomial is 3. It has 3 zeros of the 3 zeros if the polynomial is a cubic one. Okay. So if it is a straight line, it meets x-axis at only one place. So it has only 1 0. If we look at this graph, it is a parabola. By that it is showing that it is a parabola, it is a quadratic equation, and it has only 1 0. Here it is meeting the x-axis at 4 different places. 1, 2, 3, 4 places it is meeting. So it is a biquadratic polynomial. In this graph, it is meeting x-axis at 3 different places. In this graph, it is meeting x-axis at 2 different places. It is crossing the x-axis at only one place. Okay. In this exercise, we need to identify number of zeros of the given polynomial. If we take the first graph, okay, this is x-axis and this is y-axis and this is our line. So this is our line, so that this line is just parallel to x-axis. It is not meeting x-axis anywhere. So it has no zeros. The number of zero of this polynomial is 0. It has no zero at all. In this polynomial, it is intersecting the x-axis at only one single place. So number of 0 is 1. Number of 0 is 1. In this polynomial, it is intersecting the x-axis at 3 different places. So it has 3 zeros. It is intersecting the x-axis at 2 different places. So number of zeros are 2. This graph, the polynomial, intersects the graph at 4 different places. So number of zeros are 4. Here 1, 2, 3. So it has 3 zeros. Relationship between zeros and the coefficients of a polynomial. 0 of a linear polynomial ax plus b. Suppose if we take a polynomial y is equal to ax plus b. Okay. So in this, if we equalize to 0, ax plus b equal to 0, what will happen? Ax equal to minus b and x is equal to minus b by a. So if we substitute x equal to minus b by a, this polynomial become 0. Okay. So x equal to minus b by a is the 0 of this linear polynomial. Okay. X equal to minus b by a is the 0 of this linear polynomial. Zero of a quadratic polynomial. So the zeros are y is equal to ax square plus bx plus c. Okay. So this, if we equalize to 0, okay, this zeros are for ax square plus bx plus c, we can rewrite as k into x minus alpha into x minus beta. Let me multiply k into, if you multiply these two brackets, what will happen? X square minus alpha x minus beta x minus into minus plus alpha beta. Okay. So x square, here both also x coefficient. So minus we can take outside, alpha plus beta into x plus alpha beta. So along with this, one k also there. So x square minus alpha plus beta into x plus alpha beta, the whole thing multiplied by k. Okay, this is just actually equal to ax square plus bx plus c, that is equal to kx square minus k into alpha plus beta into x plus k into alpha beta. If we equalize the corresponding coefficients, x square coefficient, x coefficient and constant, if we equalize, let me see what will happen. First let me equalize x square coefficient. Ax square equal to kx square. Okay, so that this x square, if it cancels, a equal to k. So k we can rewrite as a. Okay, k can be written as a. Now let me equalize the coefficients of x. Here it is dx. dx equal to minus k into alpha plus beta into x. So this x will cancel. What will happen? Alpha plus beta is equal to this minus k we will bring here. So b by minus k. So alpha plus beta equal to, this minus we can bring to numerator. In place of k we can write a, no? So we will write minus b by a. So alpha plus beta equal to minus b by a. Okay, a equal to k, and from the x coefficient we are getting alpha plus beta equal to minus b by a. Alpha and beta are the zeros, and minus b by a are the coefficients of this polynomial. These are the relationship between the zeros and the coefficients of the quadratic polynomial. Okay, here two zeros, alpha and beta, two zeros are there, no? Like it is a quadratic polynomial, it has two zeros. So the factors we will get like this. So x minus alpha, x minus beta, in this way we have taken. So if it is a cubic polynomial, we have to take 3 factors. If it is a biquadratic polynomial, we have to take 4 factors. So that the corresponding elements we will get. So here alpha plus beta is minus b by a. Next let me equalize the constant. Here constant is c. c equal to k into alpha beta. Alpha beta let me keep here. This a, k we will bring here. C divided by, in place of k we can write a, no? So c by a. So alpha beta equal to c by a. So sum of zeros equal to minus b by a. Product of zeros equal to c by a. For the quadratic polynomial. So for the quadratic polynomial, the zeros of the quadratic polynomial are alpha plus beta equal to minus b by a and alpha beta equal to c by a. These are the two zeros of the quadratic polynomial. Okay, one side the sum of zeros and the product of zeros. Another side coefficients of the given polynomial. Here a, b, c are coefficients, no? So in terms of coefficients we have. So from the coefficients we will get directly the zeros of the quadratic polynomial. So we will see in the problem, we will understand clearly. Next, zeros of a cubic polynomial. So let me look at this also, then we will move on to the problems. So first let me take the cubic polynomial. Y is equal to ax cube plus bx square plus cx plus d. Okay, so this is a cubic polynomial. So as it is a cubic polynomial, we have to take 3 factors. So x minus alpha, x minus beta and x minus gamma. So it has 3, we will get 3 zeros, no? If it is a cubic polynomial, we will get 3 solutions for this polynomial, cubic polynomial. So we have 3 zeros. We have taken 3 factors. X minus alpha, one of the factor. From this we will get 1 0. X minus beta, one of the factor. X minus gamma, one of the factor. Let me multiply everything. K into, we have this product already for the quadratic polynomial. We multiplied already. So x square minus alpha plus beta into x plus alpha beta. Okay, that will write as it is here. X square plus alpha plus beta into x square plus alpha plus beta into x plus alpha beta. Okay. So, this is the product of first two factors. Then x minus gamma is left over, no? So, x minus gamma. Okay. So, now let me multiply that also. So, k into x square with x, with this fully we will multiply only with the x first. So, x into x square become x cube plus alpha plus beta into x into x become x square plus alpha beta into x. Next we will multiply by minus gamma. So, minus gamma x square. Gamma into x square minus gamma x square. Then minus gamma into this one minus alpha plus beta into gamma x. So, this minus is here, minus gamma x. Minus gamma x. Next, plus alpha beta into minus gamma become minus alpha beta gamma. Okay, gamma. Okay. So, now we will bring all x square, x and constant term in the order. Okay, so k into x cube, we have only one term, so let it be x cube plus this is x square and here one x square is there. Okay, in this term we have negative sign here. X square minus alpha plus beta into x plus alpha beta. Minus alpha plus beta. Okay, so here minus sign will come. So if we put minus here, so this is minus. So alpha plus beta into x square. This also x square. So minus alpha plus beta minus gamma. So whole thing we can put minus sign. So x cube minus of alpha plus beta plus gamma. So minus we have taken common outside. Alpha plus beta plus gamma into x square. Next x term. This is one of the x term. Here also one x term we have. Okay. So this is one and here one. So these two, alpha beta x plus this one, this also x square coefficient, this also x coefficient. So here alpha beta plus x, if we take common outside, what we have, alpha beta, and here this gamma is common for both of this term, no? So alpha gamma plus beta gamma plus alpha gamma plus beta gamma. Okay. So x term is this much. Next, alpha beta gamma. This constant is only 1. So minus alpha beta gamma. Okay. So but this k is common for everything. So it is kx cube minus alpha plus beta plus gamma into kx square plus alpha beta plus beta gamma plus gamma alpha. Okay, all these three terms into x is there, outside k is there, so we'll get kx minus alpha beta gamma into k. So we'll have k also here. So this is nothing but it is equal to this side we have ax cube plus bx square plus cx plus d. Let me equalize the corresponding terms. Okay. So x cube term, this is x cube term, and this is x square term. X square term is here, and x term is here. This is x term, and this is the constant term. This is the constant one. Okay. Let me come one by one. First, x cube term. The corresponding x cube term is k. Okay. So, ax cube equal to kx cube. That means x cube, if we cancel, a equal to k. Next, bx square equal to, here bx square. Here x square term is what? Minus alpha plus beta plus gamma into kx square. If we cancel x square, alpha plus beta gamma only will keep here, and we have found that a equal to k. So in place of k we can substitute a, and that minus a we will bring here. So minus, if we bring here, minus b, this multiplication become division by a. In place of k we can write a. So minus b by a equal to alpha plus beta plus gamma. Next, x term. X term is what? Cx equal to. Okay. So here what are the x terms? Alpha beta plus beta gamma plus gamma alpha into kx. So this x we can cancel. This k we can rewrite as a. So c by a. C by a equal to alpha beta plus beta gamma plus gamma alpha. Okay. Next, constant term. Which is constant term? Here d. So d equal to alpha beta gamma into k. This k we can rewrite as a. That if we bring here it become division. So d by a equal to alpha beta gamma. So what are the zeros of this cubic polynomial? Minus alpha plus beta plus gamma equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha equal to c by a. Alpha beta gamma equal to d by a. So these are all the three zeros of this cubic polynomial. By using this, how to get the zeros directly from the given polynomial, let me discuss from the problems. Find the zeros of the quadratic polynomial and verify the relations between zeros and the coefficients. Now we found all the zeros now. For the quadratic polynomial, what are all the zeros of the quadratic polynomial? Alpha plus beta equal to minus b by a, and alpha beta equal to c by a. Okay, these are all the two zeros for the quadratic polynomial. So alpha plus beta is minus b by a, sum of the terms and the product of the terms. Okay, sum of the terms and the product of the terms. Sum of the terms is minus b by a, product of the terms will be c by a. Okay, now let me find the zeros first, and we'll find the relations between coefficients. So sum of the zeros is minus b by a. No? What is minus b by a? Minus of, what is b? In place of b, this is nothing but ax square plus bx plus c. So in place of b we have minus 2. No? B equal to minus 2. So in place of minus we put already. In place of b we can put minus 2 divided by a is what? In place of a we have only 1. Okay. So minus of minus become plus. So plus 2. Okay. Alpha plus beta is 2. Sum of the zeros are 2 and the product of the zeros is c by a. Okay. What is c here? In place of c we have minus 8. Minus 8 divided by, in place of a we have 1 only. So it is nothing but minus 8. So sum of zeros and product of zeros. Okay. So first, so from this we have got the zeros, sum of zeros and product of zeros what? Now let me find the zeros first using the factorization of this given polynomial. So x square minus 2x minus 8. Okay. So if we how to factorize the constant term a into c, we can multiply and write here, and b we have to take here. So 4 2s are 8, and we have to get minus 2 now. So now it will be correct. Okay. So x square is not having any coefficient, we can write directly minus 4 plus 2. Okay. So x minus 4, x plus 2 are the factors. X minus 4 and x plus 2 are the factors. If we equalize to 0, x is equal to 4 or x is equal to minus 2. Okay. So these are the two zeros of this quadratic polynomial. So what are the sum of the zeros? So these two zeros we have to add now for getting sum of the zeros. So sum of the zeros. Sum of the zeros are what? 4 plus, this is one of the 0, the another 0 is minus 2. Okay, if we add, what we'll get? One is positive, another one is negative, we'll get plus 2. Okay, see, look at this, sum of the zeros are plus 2. Product of the zeros, we have the two zeros now. So if we multiply 4 into minus 2, what we'll get? Minus 8. So product of the 0 is minus 8. So we have verified the relations between zeros and the coefficients. So these are all the zeros and the coefficients also we have verified. So the coefficient value, from the coefficient value only we got this. Okay. So from the coefficient we are getting this one. From the zeros we are getting this answer. Okay. From the zeros. Zeros if we multiply, if we add, we are getting sum of the zeros, product of the zeros. From the coefficient directly if we take, that also we are getting plus 2 minus 8. Here also we are getting plus 2 minus 8. So we have verified the relationship between the zeros and the coefficients. So in this manner we can do this problem also. Let me do this problem. 4u square plus 8u. So here it has no constant term. So y is 4u square plus 8u plus 0. Okay. This is our polynomial. So for this polynomial what we can do? We can take 4u, we can take common outside. Suppose if we take 4u outside, what will come? U plus 2 will come, right? 4u if we take common outside, 4u square will get 4 2s are 8, isn't it? It is equal to 0. That is nothing but 4u equal to 0, or otherwise u plus 2 equal to 0. From this we will get u equal to 0 or u equal to minus 2. Okay. So if it is not having 3 terms, we will get directly. If we take the common term outside, we will get the zeros directly. So these are all the two zeros. U equal to 0, u equal to minus 2 are the two zeros of this quadratic polynomial. Okay. What are the sum of the zeros? So if we add the two zeros, what will get? 0 plus minus 2. These are the sum of the zeros. It is minus 2 itself. Product of the zeros, 0 into minus 2 is 0. Okay. As per the coefficient, what are the sum of the zeros? Alpha plus beta equal to minus b by a. Okay. So what is b? In place of b we have 8. So minus 8 divided by a is what? 4. Okay. If we divide, what will get? Minus 2. So it is coming exactly. Next, product of the zeros, alpha beta. Alpha beta is c by a. The constant term is 0, no? 0 divided by a is 4. 0 by 4 is nothing but 0 itself. So this is also verified. Okay. In the same manner, we can do this also. So y is equal to t square minus 15. So if equals to 0, t square minus 15 equal to 0, t square equal to 15. That means t what we will get? Plus or minus root of 15 we will get. So plus 15 plus root 15 minus root 15 are the two roots of this quadratic polynomial. Okay. So what are all the sum of the zeros and the product of the zeros for this quadratic polynomial? Anyway, only two terms, even though it is a quadratic polynomial. So it has two zeros. So we got the two zeros here. Okay, plus root 15 is one of the zero, minus root 15 is one of the zero. If we take a square root, we will get plus or minus now. So plus root 15 minus root 15. Okay, are the two zeros. Okay, so if we add the two zeros, plus root 15 minus root 15. Okay, both are different sign, so it becomes 0. So sum of the zeros are 0. Product of the zeros plus root 15 into minus root 15. So root 15 into root 15 become 15 itself. We have to take square root, and plus into minus become minus. Minus 15 we will get. Okay, the product of zeros. Okay, sum of zeros alpha plus beta equal to b by minus b by a. Okay, so in this term ax square plus bx plus c. Here the x term is missing, t term is missing, no? So value of b is 0. Okay, here b equal to 0, a equal to t square, it has no coefficient, so it is 1, c equal to minus 15. So a equal to 1, b is 0 and c is minus 15. So let me substitute here. So alpha plus beta is minus b by a, that is minus 0 by a, minus 0 by 1, minus 0 by 1. 0 by 1 is nothing but 0 itself. Next, product of the zeros. Product of the zeros are alpha beta. Alpha beta is c by a. Okay, what is the value of c? C is minus 15. Minus 15 divided by a is 1. It is nothing but minus 15 itself. See, both are equal. Okay, so the coefficients and the zeros. Okay, sum of the zeros and the sum of the zeros we are getting with the coefficient, both also same. So it has been verified. Sum of the zeros and the product of the zeros with the zeros and the coefficients have been verified. Next, division algorithm. How to divide the polynomials. Dividing the polynomials. So if we divide 5 divided by 3, okay, 1 3 is 3, remainder 2. Okay, so here this 5 is p of x, so p of x we are dividing by g of x, so that we will get quotient q of x and the remainder r of x. This is the general division, no? The same way, look at this. So how to check this division? 5 we are dividing by 3. It will go one time. Remainder is 2. How to check this division? So 5 can be written as, we used to multiply now this one. 3 into 1. 3 into 1 plus 2. Okay, so what we have done? This 5 is our dividend. Okay, this p of x. So p of x equal to, in place of 3 what we have? G of x. G of x. And into this one is what? Q of x. Q of x plus remainder r of x. So look at this, p of x equal to g of x into q of x plus r of x. Okay. So if we want to divide, definitely this g of x should be less than p of x, isn't it? So g of x should be less than p of x, and the remainder what we are getting should be always less than our divisor. Okay, then only our division is correct. If it is more than 3 or 3, our division is wrong. Okay, so always this remainder should be less than the divisor. So r of x should be less than g of x. Okay, sometimes it will be 0 also. This remainder 0 also will come, or remainder should be less than the divisor, but it should not be greater than the divisor. So this is known as division algorithm of a polynomial. So what is the division algorithm of a polynomial? First we have to obtain the first term of the quotient. Okay, first we have to divide. Suppose if it is 151. Okay, first we have to divide by 3. 3 5s are 15 we will get, and this we have to bring. Okay, 1 is coming. So in place of 1, if we suppose we take 4. Okay, 4 will come here. Okay, so the first division is over. So obtain the first term of the quotient, divide the highest degree term of the dividend by the highest degree term of the divisor. Okay, so if we take 15, in 15 highest possible times 3, how much it will come? 5 times it will come. Okay, so 3 5s are 15. Okay, so after dividing we have to subtract and we have to bring the one term next time. Okay, this is the actual division. Okay, so dividend by the highest degree term of the divisor, then carry out the division process. What remains is R. The remainder we will get. Now the second term of the quotient, divide the highest degree term. Okay, now we have to look at 4. Okay, in the third table 4 how many times it will come we have to see. It will come one time now, 3 and remainder 1. So we have to complete the division until the remainder should come less than the divisor. Okay, if the remainder is less than the divisor, we need to stop. Okay, in the same manner in polynomial also it will continue. Let me look at one of the division. So here p of x we are dividing by g of x. Okay, divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. Okay, let me divide these polynomials. So x cube minus 3x square plus 5x minus 3 we are dividing by x square minus 2. Okay, so let me divide now. First we have to look at the highest degree of the dividend. It is x cube and the divisor it has the highest degree is x square. Okay, so with the x square if you multiply 1x we will get x cube now. So that x should be here. Okay, so likewise we have to match this. That means x cube okay, x square, the divisor we have to take. Divisor, what we have to take to get x cube. Okay, x square is having in our divisor. Okay, with this what we take to get this whole term. Okay, so that with this if we multiply by x we will get x cube now. So with that x we have to multiply this entire divisor. So x into x square become x cube, minus 2 into x become minus 2x. So we are getting minus 2x only, it is x square, no? So we have to write this actually under the x term. So minus 2x. Okay. So now we have to change the sign. That means we are subtracting. Okay. We have to change the sign. So plus x cube minus x cube becomes 0. And in this term plus 5x minus 2x become plus 3x. Okay. And this one minus 3x square. And minus 3 is here. Okay. Now our highest power, highest term is minus 3x square. And in our divisor we have x square. So with x square, what if we multiply to get minus 3x square? Okay. So this x square is there as it is. What we need is minus 3 only. So minus 3 should be multiplied. So what we need to multiply? we have to write in the quotient place, minus 3. Okay. So now with minus 3 we have to multiply all the divisor. So minus 3 into x square become minus 3x square. Okay. Next, minus 3 into 2 become minus 2 become plus 6. That is a constant, plus 6 here. Okay. Now we need to change the sign everywhere. So this will get cancelled automatically. Minus 3x square plus 3x square becomes 0. The new sign only we have to consider. We should not consider the old sign. Okay, here what is there? Plus 3x. So 3x and this is minus 9. Okay, see, look at this. The remainder is having the highest power is 1, but in our divisor the highest power is 2. Okay, so degree is less than the divisor. Degree of the remainder is less than the divisor. So we need to stop. Okay, so our quotient is q of x will be x minus 3 and r of x is 3x minus 9. Okay, that's it. Next, another division. 4x cube, sorry, x power 4, x to the power 4 minus 3x square plus 4x plus 5. This we are dividing by, see, in this g of x it is not given in order. Better that we write in order. It is easy for us to divide. So x square minus x plus 1. X square term, x term, constant term. In this order if we write, it is easy to divide. Okay. Now we have to take the highest power term in the dividend as well as the divisor. So in the divisor we have x square. With this, what if we multiply? We will get this highest term, x to the power 4. So we have x square. With this, if we multiply x square, we will get x to the power 4. Okay. If you are multiplying the same variable, power should be added, no? So 2 plus 2 become 4. Okay, we have to multiply x square. Okay, this is our quotient now. Okay, x square. So now with this, we have to multiply this entire term. Okay, so x square into x square become x to the power 4. Next term minus x cube. See, in this also, x cube term is missing. Okay, so what we have to do now, we have to write in order. If it is not there, we can put 0x square, x cube, 0x cube. Then x square term is minus 3x square plus 4x plus 5. Okay, if any term is missing, we can put a 0. Okay, that term, coefficient we can put 0. So anyway, 0 into x cube becomes 0 only. Okay, so now when we are multiplying, we are getting x cube. Now that term we can write under this. So look at the second term. X square into x become x cube. Minus into plus become minus. So minus x cube. Okay, that means minus 1. Okay, next plus 1x square. Plus 1x square. Now let me subtract. So when we are subtracting, we have to change the entire sign. The positive means negative. Negative means positive. We need to change the sign. And plus x power 4 minus x power 4 becomes 0. Plus 0x cube plus 1x cube become 1x cube. Here both are negative sign. This sign we should not consider. This is our new sign. So minus 3 minus 1 become minus 4. Minus 4x square. Next bring these two terms also. Plus 4x plus 5. Now the highest power is x square, x cube. Here highest power is x square. So with x square, what if we multiply? Okay, this term we will get 1x cube we will get. Okay, so we have to get x cube. We have x square. Only 1x is needed. So that is our coefficient now. That is our quotient. So plus x. So with this x we need to multiply everything. So x into x square become x cube minus x square. Next term plus x. Okay. So now we will change the sign. Minus plus minus. If it is positive, we have to put negative sign. If it is negative, we need to put positive sign. Okay. So this will get cancelled. Here minus 4 plus 1 become minus 3x square. And here it is 1 now. Plus 4 minus 1 become plus 3x plus 5. Okay. So now our divisor is x square, and here the highest term is minus 3x square. So we have x square, only we need to multiply minus 3. So that minus 3 is our quotient now. So with this minus 3 we need to multiply everything. Minus 3 into x square become minus 3x square, and minus into minus become plus 3x and minus 3. Okay. So what shall we get? We need to change the sign. So if we change the sign, it is positive. Here negative. This is positive. So minus 3 plus 3 becomes 0. Plus 3 minus 3 becomes 0. Here plus 5 plus 3 become plus 8. Okay. So what is our quotient and remainder? Quotient q of x is x square plus x minus 3. And the remainder is plus 8. Okay. This is our answer. So in this manner we can divide this also. Here which is having highest power we need to consider as the dividend. The another will be the divisor. Okay. So this is our dividend. This is our divisor. We need to divide. Try this one. Next one. Find a quadratic polynomial each with the given numbers as the sum and the product of its zeros. So sum and product of the zeros are given. Okay, with the sum of the zeros and product of the zeros, we need to find the quadratic polynomial. So according to what is the polynomial? X square plus alpha plus beta into x plus alpha beta. This is the polynomial. Okay, the sum of zeros are the coefficient of x and product of zeros are the constant. Okay, so sum of the zeros, it is given that sum and product of its zeros. That means sum of the zero is respectively. That means first one is sum of the zero and the second one is product of the zero. Okay, so sum of the zero means alpha plus beta is 1 by 4 and alpha beta is what? Minus 1. Okay, let me substitute here. X square plus 1 by 4 into x minus alpha beta is what? Minus 1. Okay. These are all the sum of the zeros and product of the zeros. Okay. So that now 4 is in the denominator. We should take LCM. So 4x square plus x minus 4 equal to 0. This is the polynomial. Okay. So we have to find the quadratic polynomial for the given sum of the zeros and the product of the zeros. Come to next problem. Here what are the sum of the zeros and product of the zeros? Alpha plus beta equal to root 2. Alpha beta equal to 1 by 3. Let me substitute. So x square plus alpha plus beta is root 2. So root 2x plus alpha beta is what? 1 by 3. That is equal to 0. So one number is having the denominator 3 no. That we take LCM. So that we have to multiply this 3 with other terms. So that we'll get 3x square plus 3 root 2x plus 1. This 3, denominator 3 if we bring with 0, whole denominator 3 we will get no. But 3 if we bring here, 0 into 3 becomes 0. So the denominator we can leave. Common denominator 3 we can leave. So this is our quadratic polynomial. Come to this one. Here sum of the zeros alpha plus beta equal to 0. And alpha beta is root 5. Okay. So that what is the polynomial? X square plus alpha plus beta is what? 0x plus root 5. That is equal to 0. So x square plus 0x, no, this term we can leave because it is 0. 0, whatever we multiply, it becomes 0 only. So x square plus root 5 equal to 0. This is the quadratic polynomial for this zeros, sum of the zeros and the product of the zeros. Next one, obtain all other zeros of this polynomial if two of its zeros are given. Okay, square root of 5 by 3 and minus square root of 5 by 3. Two zeros are given. Okay, actually what type of polynomial it is? The highest power is 4, no? So it is a biquadratic polynomial. So if the highest power, the degree is 4, we will get 4 zeros, no? So 2 zeros are given. We need to find the other 2 zeros. Okay, so how to get other 2 zeros? Actually, these two are the zeros of the polynomial. That means x is equal to square root of 5 by 3, isn't it? And x is equal to minus square root of 5 by 3. Okay, so these are the 2 zeros of this polynomial. So these values if we substitute, okay, this polynomial becomes 0. Okay, these two are the 2 zeros. We need to find other 2 zeros. Okay, so x is equal to square root of 5 by 3 means x minus square root of 5 by 3 equal to 0, and x, this minus we bring here, plus square root of 5 by 3 equal to 0. Okay, so these two are the factors. So these factors if we multiply, so this is the factor of this given polynomial. This separately is the factor of this polynomial. The product of these two factors also a factor of this polynomial. So factor means definitely it is exactly divisible. Suppose for 12, 4 is a factor means, okay, each of its factors are exactly divisible. Okay, so this is a factor means it is exactly divisible. This polynomial is exactly divisible by this factor. This polynomial is exactly divisible by this factor. So that means 12 is divisible by 2 and 12 is divisible by 3. That means 12 is divisible by 6 also. With this product also it is divisible. Okay, so if it is divisible by 2 and if it is divisible by 3, definitely the given thing is divisible by the product of the factors also. So the product of the factors, let me find x minus square root of 5 by 3 into x plus square root of 5 by 3. So here it is a minus b and a plus b format it is. So we will get x square minus square root of 5 by 3 the whole square. Okay, so square and root will get cancelled. We will get x square minus 5 by 3 equal to x square minus 5 by 3. Okay, so this is x square minus 5 by 3 also one of the factor of this given polynomial. Okay, its product also, the product of these two factors also a factor of this polynomial. So if it is a factor, definitely it is divisible by this factor. Okay, so so these two are the factors of this polynomial. So how much is left over with this? We need one more 2. Okay, so that it is exactly divisible. Okay, so likewise something is left over for getting exactly divisible. Okay, now with this if we divide, it is exactly divisible, but we will get some quotient. Okay, so likewise like this, this 2 is the quotient now. This 12 if we divide by 6, we will get 2 as the quotient. That means 2 is the one another factor we have. Okay, that we need to identify which is the another one factor. For that, we have to divide this given polynomial by this product. Okay, so let me take this polynomial 3x to the power 4 plus 6x cube minus 10x minus 5. Okay, this polynomial we are dividing by x square minus 5 by 3. Okay, by this we are going to be dividing. Okay, so first we have to take the first term and the highest term of the given polynomial and the divisor, highest term of the divisor. Okay, we need to get x per 3x power 4. We have x square. With this, what if we multiply? We will get 3x to the power 4. Okay, so x square is there. We need one more x square and 3 also needed. So 3x square we have to multiply. So 3x square is our first quotient. Okay, now with this 3x square we need to multiply everything. Okay, so that is x square minus 5 by 3 into 3x square. If you multiply x square into 3x square, 3x to the power 4 And with this term, if you multiply minus 5 by 3 into 3x square, what will happen? This 3 will get cancelled. So 5x square we will get. So 3x to the power 4. Okay, here x square term is missing, right? X square term is there. Left. Wait. Okay. So 6x cube minus 2x square minus 10x minus 5. Okay. So what is our x square term? It is minus 5x square. Okay. Minus 5x square. We'll write under the square term exactly. Okay. So that we need to change the sign now. Okay. So we'll get, this will get cancelled. And under x cube nothing is there. So we'll write this as it is. Nothing to subtract. So 6x cube. Here it is minus 2 plus 5 become plus 3. Plus 3x square minus 10x minus 5. Okay. Now the highest term is 6x cube. We have x square. With this, what if we multiply? We will get 6x cube. Okay. So we need 6x. X square into x become x cube. We need 6 also. So we have to multiply by 6x. 6x. Okay. So if you multiply by 6x, what will you get? Okay. So x square into 6x minus 5 by 3 into 6x. Okay. Here this will get cancelled. And this will become 6x cube minus 10x. Okay. So, what we are multiplying? By 6x. So, what is the product we are getting now? Here, 6x cube minus 10x. Okay, as it is a factor, definitely should divide exactly. We will get remainder 0 only. Until that, we need to divide. Okay, so this is negative and we will have to change the sign here. So, this will go, this also will go. See, now it is 3x square minus 5. So, look at this, this is x square, this is also x square, so we can divide, Why? Because if it is less than the divisor only, we have to stop. So, degree is equal, so we can divide. So, this is also x square, this is also x square, only 3 is needed extra. So, we have to take 3 now, okay. So, 3 into x square, 3x square, second term is minus 5 by 3 into 3. Okay, so this 3 will get cancelled. 3x square minus 5 we will get. That only we have exactly here. So 3x square minus 5. If you multiply 3 with this. X square minus 5 by 3. If you multiply by 3, we are getting 3x square minus 5. We need to change the sign now. So if we change the sign, plus 3 minus 3 becomes 0. Minus 5 plus 5 becomes 0. What is our quotient now? 3x square. 3x square, what is the sign here? We have taken plus 6x only now. So, plus 6x, sorry. Plus 6x plus 3. Okay, 3x square. 3x square plus 6x plus 3. Okay, from this we will get quadratic equation. We will get 2 factors now. Here, everything is divisible by 3, no? So, let me take 3 common outside. So, what we will get? X square plus 2x plus 1 is equal to 0. That means 3 we can leave because 3 if you bring here 0 by 3 becomes 0. So, our equation will be x square plus 2x plus 1 equal to 0. Okay. So, here a and c if you multiply 1 we have to get 2. 1 is 1. 1 plus 1 become 2. Okay, so x square is not having any coefficient. We can write directly x plus 1 into x plus 1 equal to 0. That means x is equal to minus 1 and x equal to minus 1. So, the 4 zeros are, we have already square root of 5 by 3 and minus square root of 5 by 3. And here we got now minus 1 comma minus 1. So these are all the 4 zeros of this biquadratic polynomial. Next question. On dividing this polynomial by g of x, the quotient and remainder were x minus 2 is the quotient and minus 2x plus 4 is the remainder they are telling. We need to find g of x. That means x cube minus 3x square plus x plus 2. This is our polynomial. We are dividing by g of x. G of x is not given anything. Okay, we are dividing by g of x. Our quotient is minus quotient and the remainder are respectively. That means the first one is the quotient, the second one is the remainder. So x minus 2 is the quotient and the remainder is minus 2x plus 4. Okay, we need to find g of x. So how to find this g of x? We have to find g of x only. Okay, so suppose 12, if we are dividing by a number, we will get 3 as the, suppose it is 13, let me take. So we are dividing by a number, so that we are getting 3 as the quotient and 1 is the remainder. How to get this one? That means, okay, so in third table, how many times this 13 will come? 3 4s are 12. Okay, so remainder 1 we are getting now, so it might be divided by 4. Okay, so that what we can do, these two if you multiply and if we add 1, we will get this one now. So 4 3s are 12 plus 1 become 13. This is the way of checking the division. In the same manner, here g of x into x minus 2 plus minus 2x plus 4. If we add the remainder, we will get x cube minus 3x square plus x minus 2. Okay, so g of x into, that means divisor into quotient plus remainder equal to dividend. Okay, t of x equal to g of x into q of x plus r of x. t of x equal to g of x into q of x plus r of x. Okay, t of x I wrote this side, that's it. Okay, so now we have one equation, isn't it? It is having equal sign here. It is an equation. Everything in terms of polynomial, only this g of x is unknown. Okay, so if we simplify this, we will get this g of x. Let me try to simplify. Okay, how to simplify? Only g of x will keep here. The other things we can bring this side. Okay, but first addition, then only multiplication. Okay, so this addition, let me bring this side according to board mass. Okay, this addition should bring this side first. Okay, so g of x into x minus 2, let me keep as it is. The separate term will bring this side first. So x cube minus 3x square plus x minus 2. Okay, this plus this expression, if we bring here, minus of minus 2x plus 4 we will get, isn't it? This plus this polynomial, if you bring here, minus of this polynomial will come. Okay, minus 2x plus 4 exactly inside this bracket. Okay, so what we will have, we can remove the bracket by multiplying this sign. So x cube minus 3x square plus x minus 2, and here plus 2x minus 4. Okay, so x cube minus 3x square, and with this 2x term we will get plus 3x minus 2 minus 4 become minus 6. Okay, so x cube minus 3x square plus 3x minus 6. Okay, now this is in multiplication. If you bring, it will become division. Okay, so that g of x equal to this polynomial divided by x minus 2 will come. That means if we divide these two polynomials, we will get g of x. Okay, let me divide. So 3 x cube minus 3x square plus 3x minus 6. We are dividing by x minus 2. Okay. So first term we have x. Here we need x cube. So we have to multiply by x square. Okay. With this x square we have to multiply everything. X square into x become x cube. Okay. Minus 2x square. Okay. So let me change the sign. So this will get cancelled. Plus 3 minus 3 plus 2 become minus 1. Minus 1x square plus 3x minus 6. Okay. Now the highest term is minus 1x square. So we have x. We need one more x. So minus x we need. So minus x into x become minus x square. And the next term will be minus into minus become plus 2x we will get. Okay. So this, if we change the sign, these two will get cancelled. Plus 3 minus 2 become 1. Isn't it? Plus 1 will get. So x minus 6 will come. So we have x minus 2 as the divisor and our quotient also x minus 2. So what we need here? Nothing is needed. So we'll take one time everything. So 1 time x is x, 1 time minus 2 is minus 2. Let me change the sign. So this also will get cancelled. Everything will get cancelled. Our remainder is 0. Okay. So if we divide by the product, okay, of everything, at last we are getting g of x equal to x square. Our quotient is only the answer, no? Our quotient is x square minus x plus 1. So our g of x is x square minus x plus 1. That means g of x is this division. This division we done here. The answer of this division is this quotient only. So g of x equal to x square minus x plus 1. That's it. Okay. Now we'll move to fifth problem. So what is asked? Give examples of polynomials p of x, q of x, g of x, r of x which satisfy the division algorithm. Okay. So we have to give our own polynomial to satisfy this given condition. Degree of p of x equal to degree of q of x. Degree of p of x and degree of q of x must be equal. That's it. Okay. Both of the degree should be equal. Okay. Suppose if we take p of x equal to 3x square minus 6x plus 27 and g of x will be x square minus 2x plus 9. Okay. So it is coming multiples. Okay. Exactly with the multiples. The numbers we have to take in multiples so that it will be divisible exactly. There is no remainder and everything is equal also. Okay. What they are asking is given here. Okay. So degree of p of x. The highest power of this polynomial is 2. The highest power of this polynomial also 2 only. So both of the degrees are equal. So these two we can take as example for the first one. Come to next one. Degree of q of x and degree of r of x must be equal. So like that we have to take polynomial. If we take polynomial 2x cube minus 2x square plus 2x plus 3. Okay. This polynomial if we divide by 2x square minus 1. Okay. So that we will get quotient as x minus 1 and the remainder as 3x plus 2. That means we have to take p of x and g of x in that manner that the degree of the quotient and the degree of the remainder must be equal. So if we take like this and if we divide, we will get the degrees of both of this become equal. Okay. So in this the degree of q of x is 1. Degree of the remainder also 1. So both of these are equal. Degree of q of x and degree of r of x must be equal. Okay. Now the remainder becomes 0. Okay, we have to get remainder 0. Okay, so for satisfying that we have to take the polynomial. Okay, suppose 2x cube minus 4x square plus x plus 4 divided by 2x square plus 1. If we divide the quotient, what we will get? No, x minus 2, and the remainder is 0. Okay, so degree of r of x is 0. If we have at least one term, okay, degree become, but sometime degree can be what? Here, yes, instead of 0, we are getting 6 as the answer at last. The remainder is 6. But even though degree is what? Degree is 0 only now. If it is a polynomial, it is a constant. Okay, with this x to the power is 0. Okay, so degree is 0 only. If it is a constant, the degree is 0. Either it can be some other polynomials you can take, like a degree, sometimes remainder can be 0 also for getting degree 0. Or remainder can be any other constant. Okay, instead of getting, it is a linear polynomial, degree is 1. If you want to get a constant polynomial, degree is 0, so that this should not happen. Okay, we have to get only 2 at last. 2, 3, 4, 5, any number, or otherwise 0 also can be possible. So in that manner we have to take 2 polynomials. If we divide, we will get like this. Okay, so if you want to get degree 0, better like this we have to take. Okay, 2x cube x square if we take, okay, it is possible to get the remainder as a constant polynomial or 0. So like this, solve as many problems and check the degrees, coefficients of the polynomials. Okay, zeros of the polynomial, sum and the product of its polynomial. Okay, sum of the zeros and the product of the zeros of a quadratic polynomial. Cubic polynomial also I have explained how to get the sum of the zeros and product of the zeros for the cubic polynomial. So practice everything. Thank you.